Here, we're given that W is equal to e to the power of x squared minus y squared. You must write an expression for the total differential W of W, which we call dW. Alright, so I'm going to ask you to pause the video and make an attempt at that. Okay, have you finished? So here, the total differential. What we have here is that the W is going to be the partial derivative of W with respect to x times dx plus the partial derivative of W with respect to y times dy. Alright? Remember, d is a change. You're looking at a change in x and a change in y. This is somewhat like traveling in two legs of a journey. In this case, you have the rate of change of distance in kilometer with time times, remember distance is speed, this is what we call speed, multiplied by time. Alright? D time, the change in the first leg of the journey. You traveled at 50 kilometers per hour for 2 hours. Plus, after you stop at some restaurant and you continue the journey after that, you may travel at 60 kilometers per hour for another 1.5 hours. So you have both legs of the journey added up to give you the total distance traveled. It could be you have 2 contracts for the week. The rate of change of money that you make per rate of change of day times number of days in the first leg of the journey. In the first part, the first contract. So you are paid $3,000 per day. $3,000 per day, and you work for 3 days. That's rate at which dollars change per day for 3 days plus. And then you have another contract. You are paid $4,000 per day for another 2 days. So you add up the total amount of money. Those are the only 2 contracts you get for the week. So that's DW, the change in money. Your account, how did it change from the start of the week to the end of the week? This is how it changed. All right. So it's the same idea. All right. So let's get back to this now. We say that we have dW is delta partial of W, which is by partial x dx plus partial of W by partial y dy. So here, what is partial of W with respect to x? Partial W by partial x. Alright. Now, if you have been practicing your chain rule, you'll be able to see how this works quickly. This would be, you have a function here, function of a function. This is called the inside function. If you differentiate it with respect to x, you get 2x. So you're going to find the partial with respect to x of x squared minus y multiplied by then the partial with respect to e to the x minus y squared of e to the the partial with respect to x squared minus y squared, I should say, my mistake, of e to the x squared minus y squared. That's the idea behind it. Derivative of the inside function times the derivative of the outside function with respect to the inside function. Now, you would have been doing it this way before. So let's look at it like this. I'm not going to erase this part yet. Let u be equal to e to the x squared minus y squared. You see that? No. Alright. Let u be equal to x squared minus y squared. That's what I wanted to write. Alright. If that is so, then what happened? W is equal to e to the u. You see that? This is u, you know. So you have e to the u for w now. Alright. Now, if you say you want the derivative of w with respect to x, then what you're going to have, right, is going to be the derivative of w with respect to u times the derivative of u with respect to x. The derivative of u and the derivative of u would cancel, leaving derivative of w by derivative of x, right? Now, what is the derivative of w with respect to u? Remember, w is equal to e to the u. You remember that when you differentiate y equal e to the x, dy by dx would be e to the x. You have to remember that by now. It's the same thing that applies here. When w is e to the u, then the derivative of w with respect to u is e to the u. Right? So we have this part. Now what about u and x? U is equal to x squared minus y squared. So you have it here. Right? Now the derivative of u with respect to x is going to be 2 times x, 2x. Well, it's just 2x. So what you have is that the partial derivative of w with respect to x is e to the u times 2x. You could write it as 2x e to the u, but what is u? U is x squared minus y squared, so it's x squared minus y squared. Alright? Similar idea here. If you should work it like this mentally, you would have 2x here, so it's 2x times e to the all of this, which we had called u. Right? We just simplified it by giving it a name with just one letter, e to the u. So it's e to the x squared minus y squared. That would be what that is. Alright? So this was just a revision of using the chain rule to work on this. Okay, so let's go back to where we were. You use the chain rule and you found that partial w by partial u is 2x e to the x squared minus y squared. Now, here, let's look back at this. Let's rewrite it. W is e to the x squared minus y squared. So again, we have w is e to the x squared minus y squared. What we want here is partial w by partial y. So what do you think the derivative of w by y is? When you The same argument before applies, but you're going to differentiate it with respect to y. You're going to get negative 2y times e to the all of this you would have called u, so it's e to the u, so it's e to the x squared minus y squared. You see that? After that now, dw equals, now remember, partial w by partial x is partial w by partial x. Why did I write u here? It should be x here, no? By partial x I should have had. I was looking at this when I was writing this down, but it's partial w by partial x that I should have. See it here? So what you have is 2x e to the x squared minus y squared, and what was beside it? dx times dx. See that? Alright, plus, and then what we have here is the partial w by partial y of the partial w by partial y is really negative 2y e to the x squared minus y squared. Alright, so dy. Alright, so that's dy there. Alright, so what we have here, we could simplify. Suppose we factorize and say e to the, alright, we have 2 e to the x squared minus y squared. So we have that. Open bracket. Inside the bracket we have 2 dx minus y. No, it would be x dx, not 2 dx. We factor out the 2 already. This would be x dx minus, this is like y dy. Right, so that's what we have there.